Welcome back to Algebra with Miss Swartz. Today we are going to be looking at solving systems a different way than we did before our break. So today we're going to be looking at solving systems using substitution. Okay. Previously we solved systems by graphing. Remember, a system is a set of equations that are in two variables. And to solve these equations, or to solve the system of equations, we have to find an xy value that makes both equations true. So far we learned how to graph. When we talked about graphing, we were looking for where those graphs cross because those points were both on the graph. Today we're going to learn a different way. Using substitution, we're going to talk about what that looks like. So there's going to be about 5 examples that you write down, or 5 things you need to write down today. So you're looking for those 5 things. And let's get started. So this first part is actually in your journal, and you can write it in there because I think it's good just to kind of work through this. So it says solve each system of linear equations using 2 methods. So we're going to actually use both methods to show you that either way would work, and we can work with equations this way. So for our first method, it says solve for x in one of the equations. Okay, well, if I look at A here, which equation looks like it would be easiest to solve for x for? If I solve for x here, all I would really need to do is subtract y. If I solve for x here, I'd have to subtract y and then divide by -5. So if I'm going to solve for x in one of the equations, I'm going to go ahead and solve for x in that first one. So x is going to equal -7 minus y. Okay? So then it says substitute the expression for x into the other equation to find y. Okay, so let's take that step by step. So since I know this is what x is, I'm going to substitute, hence the word substitution, this in wherever I see x. So now I only have one variable in my equation, and I can work to solve for y. So I need to distribute to start. So I'd have 35 plus 5y, because a negative times a negative is a positive, plus y equals 5. And I'm going to come over here. I'll have to do a lot of erasing. But then I'm going to combine any like terms I have. So 5y plus y is 6y plus 35 equals 5. Finally, I'm going to subtract 35. I get 6y equals -30. Divide by 6, so y equals -5. Okay, so there I found y. This is my y value that's going to make both true. It says then substitute the value of y into one of the original equations to find x. Well, I'm going to plug it into the easier one in my opinion. So x plus -5 equals -7. So I'll add 5 to both sides. So x should equal -2. So now I have my 2 pieces. And I can check to see if I did that correctly. If I plug in -2 and -5, -2 plus -5 gives me -7. And then if I check, -5 times -5 is 35. Plus, oops, I gotta use x here, my bad, sorry. -5 times -2 is 10, plus -5 is +5. So I know that I did that right. So that's the first method that I can use with this one. The second one is I'm solving for y first. So I'm going to go ahead and erase what I did. Remember, I got -2, -5. And you're going to come to see that either way works.
Attention students.
Sorry about that. Alright, so method 2, if I solve for y first, I'm just going to subtract x from both sides. So I end up with y equals, I could do negative 7 minus x or negative x minus 7, either way. Okay, so now my goal, now what I'm going to do, it says solve y for one of the equations, then substitute the expression for y into the other equation to find x. So now I'm doing the same thing, I'm substituting in for y. I didn't have to distribute here, I just have to combine my like terms. Negative 5x plus negative x gives me negative 6x minus 7 equals 5. Then I'm going to add 7 to both sides, so I get negative 6x equals 12. And what do you know? X equals negative 2. That's what we got before, is it not? So now I'm going to substitute the value of x into one of the original equations to find y. So negative 2 plus y equals negative 7. If I add 2 to both sides, y would equal negative 5. So, did I get the same thing both times? Negative 2, negative 5? I, in fact, did. So, I should be good to go. So, the question is not, should I use method 1 or 2? I can use either or. It's determining maybe which one would be easiest. So, down here the question is, which one would you prefer to use for each system? Well, for this one, I don't think it really matters too much. You have the same amount of work here. The only difference might have been that you could maybe have more mistakes when you're plugging in when you have to distribute them versus when you don't. So solving for y might have been better there. Okay, for space sake, I'm actually just going to do C. You're going to try B on your own using both methods in your journal on page 137. So for C, I'm just going to determine which one I think might be easiest to use. Now, could I do both methods? Sure. And for B, I want you to try both methods. But for C, I'm just going to determine which one would be easiest. I'm going to kind of talk through how I would do that. So remember, we're trying to get one of our variables alone first. So when I look at C, I only see one variable in all of my variables that is already alone without any work. I just have to get rid of one other term. So what I'm going to do is first solve for y. I'm using method 2 here in this case. So I have y equals negative 4x minus 1. Now I'm going to take what I have, and since I have y equals something, I'm going to plug that in where I see y. So I have 3x minus 5 times negative 4x minus 1. That is y, so I'm plugging it into that point, to that spot. I should probably distribute here, but I'm going to make sure I do keep change there. So I have a negative 5, and I'm distributing that into all of the inside the parentheses. So I get plus 20x plus 5 equals negative 18. So when I combine my like terms, these out of the way, I get 23x plus 5 equals negative 18. Then I will subtract 5, so I get 23x equals negative 23, and divide by 23, so x equals negative 1. Now you could plug this x back into either of these problems to try to solve for y. So I'm going to plug it back into the first one. So I have 4 times negative 1, which would give me negative 4, plus y equals negative 1. So I'm going to add 4 to both sides. So y equals 3. So my ordered pair then would be negative 1, 3. That's where the graph would cross, etc., etc. I should probably check this. So I got negative 4 plus 3 gives me negative 1. That is true. And if we did 3 times negative 1, we get negative 3 minus 5 times 3, which would be 15. So we get negative 3 minus 15, which would in fact be negative 18. Okay, so I do want you to try that B in there, but if you want to watch me do the next few examples that I'm going to do before you do B, that is fine. But here are kind of the steps. It says step 1, solve one of the equations for one of the variables. Step 2, substitute the expression from step 1 into the other equation and solve for the other variable. So you're substituting it in wherever you see that variable, that letter. Substitute the value from step 2 into one of the original equations and solve. So you kind of have 3 major steps there that all require some math. Let's try this one together. Okay, now if you notice, equation 1 already has y by itself in this case. So that makes our life a little easier. That kind of eliminates step 1 for us. Y is by itself, so I can plug y into the second equation. So I have 6x minus 5 times, okay, and I'm going to plug in what I see for y, negative 2x minus 9, and that should equal 19. So be careful with your sign here. I'm going to distribute my negative 5. Okay, and then I need to combine some like terms. So I get 16x plus 45 equals negative 19. Finally, I need to subtract 45 from both sides. So really what I'm doing is adding here. That's going to give me 64, but it's going to be negative, and that equals 16x. So I'll finally, last step there, divide by 16, and you see why you have to be so good at solving equations here, but x should equal 4. So now I can choose, do I want to plug it into here, into equation 2 or equation 1? Probably easier to put it into equation 1. Because then I just have to solve using order of operations. So negative 8 minus 9, so y should equal negative 17. So my ordered pair then is 4, negative 17. Well, I want to check that really quickly. So negative 17 should equal negative 2 times 4 minus 9. Well, we should know that that's true based on this. Check it into the other one, we get 24 minus, oops, I lied. No, that's right. 24 minus, so negative 5, we'll do plus a negative, so negative 5 times 17. It's going to be a positive 85. We should double check. I think I might have made a mistake. I see where I went wrong. Negative 64 divided by 16 has got to be negative 4. So then when we come up here, that's going to change kind of our answer here. If we have negative 4, this would be a positive 8. And then we would be working with a negative 1 as our answer. So then when we go to plug that into here, that will work as well. Negative 1 equals negative 4 times negative 2 minus 9. There we go. Alright, so now let's try plugging that into here, which should give us a better answer. So we get negative 24 plus negative 5 times negative 1, which would give us a positive 5, which would in fact equal negative 19. There we go. Simple mistake can lead to some big errors, so be careful as you're working. All right, last example for you, just for sake of time. Okay, so you can make this decision. What do you want to get alone? Here, in both cases, it'd be easiest to get y alone one way or another. Whether you start with equation 1 or equation 2, doesn't matter. Let's just start with equation 2 since we haven't done that yet. So I'm going to subtract 3x, and we get y equals negative 3x minus 1. So then I'm going to go ahead and plug what y is into equation 1. So I have negative x plus negative 3x minus 1 should equal 3. combine my like terms. So I get negative 4x minus 1 equals 3. I'm going to add 1 to both sides. I get negative 4x equals 4. And then I'm going to make sure I keep my negative with that, and negative 1 should be my answer there. Now again, I could plug it into either one. If you plug it into this first one, be really careful. You'd have a negative, or the opposite of the negative. Okay, so that's fine. So you'd have negative times negative 1 plus y equals 3. And remember, we're looking for y. So we'd have 1 plus y equals 3. Subtract 1, so y would equal 2. So our answer would be negative 1, 2. We should make sure that works. So we would have, obviously, here prove that that one works. So 3 times negative 1 would be negative 3 plus 2 should equal negative 1. That's true. So we are good. Tomorrow we'll look at some story problems with that. We don't have quite enough time for the video today. It just gets too long. So your homework is in your journal, page 140. It's just those types of substitution problems. If you have questions, make sure you ask. Have a wonderful day.